Right, gents, up until today, I've just told you to just go northwest or southeast. But now we're going to look at a more accurate way of describing direction. I don't know where they are. Take that one. That's Rex's. So there are two types of bearings. Doesn't really matter which one you use. So here's our little cardinal axes. Let's go north, south, east, and west. Let's draw in a vector, like so, and call that 40 degrees, and let's call that 3 meters. Okay? Now this is very, very simple. The steps are very simple. Step 1, you state the closest cardinal axis. Now what the cardinal axis is the north, south, east, and west. Okay? So obviously this vector is closest to the north axis, so we're going to say north. So our completed vector, let's just go down here, our completed vector, we're going to write S equals 3 meters north, and we'll complete this. The next step, you then describe, or state how many degrees from that axis. And from this diagram we can see that it is 40 degrees. So we'll go down here and go north 40 degrees. And then the last one, in which direction? In this case, well, if you're stating north, you can either be west or east. In this case, the vector is 40 degrees east from north. So our final vector is 3 meters north, 40 degrees east. Okay? Because remember, inside that quadrant, that northeast quadrant, there's an infinite number of directions. It just depends on how many decimal places you choose. You could have 40.4. You could have 40.43758. It depends on how precise you want to measure it. Okay? It's very, very simple, guys, and you've learnt this in mathematics. When I say tricky, it's not that tricky. Let's just go back up to this diagram. Our knowledge of complementary angles, we know that if that's 40, then we could write 50 here. And so we could say that that vector is east 50 degrees north. But generally we want to simplify it. We want the simplest expression of direction. And in this case, 40 degrees is less than 50. Okay, so technically it's correct, but we wanted to always choose the closest cardinal axis first. So that's what we said. We might be given the complementary angle. Let's have a look at this example down here. I'm going to draw a vector like so. Hopefully it's a straight line. 10 meters, and let's give you that this angle is 70 degrees. North, south, east, and west. Well, all we need to do is find the complement. So this angle here is going to be 90 less 70, which equals 20 degrees. That's pretty simple. If I gave you the angle that it's not, you should be able to calculate the angle that it is. Okay, so in that 90 degree wedge, 70 degrees is not, so the remaining is 20. So this guy here would be S equals 10 meters west, 20 degrees south. Okay? Easy. Yeah? All right. There are some vectors, and in just a moment you're going to draw them. They're going to be very, very simple. But could we please turn the page? And let's look at the other type of bearing. Okay, so we looked at conventional, where it's north 20 degrees east. This one, we start north and we rotate clockwise. So instead of writing north, south, east, west, could I get you to write 0 degrees, 90 degrees, 180 degrees, and 270 degrees? Okay? So, if I gave you another vector like this, seven kilometers, how many degrees from north? 120, absolutely. So you go 90 plus 30. So again, we could write S equal, now the conventional bearing would be east 30 degrees south, or we could say S equals 7 kilometers, not zero, we need a 3-digit number, 120 capital T. So the capital T is just telling us that it's a true bearing. Okay, it's a little bit silly. I don't really like true bearings. It's like saying, if I want to point someone in that direction, I could say, right, start north, and then rotate yourself 90 and 30. You've rotated 120 degrees. Now you're facing in the right direction. It would be much simpler to say, east 30 degrees south. That's a lot simpler. You're not going to point someone north and then like grab them by the shoulders and then rotate them around. Okay, but they're both engineering, or you might use this in orienteering or using maps, cadets, no, conventional, geography, who knows. Let's do one last one. Here's the next tricky one, and again, it's not that tricky because you guys are good at maths. You could be given the angle that's past clockwise. So what if I gave you, and that should be a straight line, what if I gave you this was 50 degrees? In which case, we need 90, 180, 270. We've got to figure out what this wedge is here. That wedge there is 40 degrees. And so you go 270, rotate an extra 40. Let's give a bit of magnitude. Let's go 8 kilometers. So we go S equals 8 kilometers. 270 plus 40 would be 310 capital T. Okay? And that was the tricky thing. It says sometimes you're given the angle past your direction. For when we were given the 50 degrees up here, well, if that's 50 degrees to 360, you could just subtract 50 from 360, or you could add 40 to 270. Doesn't matter how you get there, as long as you express this. What's it called? Is it a reflex angle? Yeah, it's a reflex angle past 180 degrees. Cool. And then you've got some vectors to draw. So could you do that now for me, please? On the first page, you've got to draw those 4 vectors and label them. And then on this page, 3 vectors, I should say. Okay? They're all in centimeters, so I want you to use your ruler and draw them to scale. Okay? No, you don't need a scale, but you can draw them to scale, meaning, your 2 centimeter vector should be half as long as your 4 centimeter vector. No, you don't need a protractor. Just try and pick. So, for example, 30 degrees. I'm going to draw it closer to north than to west. So, I'll tell you now, when I'm marking your tests, I'm not going to sit there with a protractor and measure every single, or I'll be there for hours. Five centimeters north, 80 east. Two centimeters south, 45 west. Right. Okay. Who's drawn all three vectors? Good. Now, what I'd like you to do is write the other type of bearing next to the bearings. So, on the conventional bearing page, I'd like you to write the true bearing next to it. And on the true bearing page, I'd like you to write the conventional. Okay? So this one here, ooh, geez, what are we doing? Make me think. North 30 west. Well, that's going to have to rotate 330 degrees, I think. Okay, that's what I want you to do. Okay? One thing, it's a 3-digit number, so you don't write 80, you write 080, capital T. It's a bit silly to think, but if it was 5 degrees north 5 degrees east, it would be 005. Okay? Then this one, 180 plus 45 is 225. Yeah? And I don't want to spoil the fun, so you can do this one on your own without me writing it. Yeah, so these ones on the screen right now, you need to convert those to conventional bearings. So, east 10 degrees. I'm spoiling it. You do it, Peter. Do it. And while you do that, I'll do attendance. We're missing Rex. That's. I know. Oh, still got to do attendance. Rocket, what's up? Question? No? There's no answers. You just got to wait for me, I guess. There are no answers.
How do you know?
So what's this guy going to be? We said it was east 10 degrees south. This one is south 20 degrees west. And this one is north 10 degrees west. Yep. Cool beans. Yes?
Do we need to drawing the angles as well?
No, that's alright. You don't have to. Okay. Alright, and that is it for bearings. But we are going to have to come back to it in our next lesson, which is right now. So, turn the page. We're going... What? You can check it on the OneNote this afternoon, in your own time. Yeah? Or I'll just wait another 5 seconds. Cool. All right. Let's get to the fun stuff. Pythagoras, vectors. Okay? Well, yeah, okay. There's no need to shout out. Now, gentlemen, if we are given, have a look at the page, if the vectors are at right angles to each other, then essentially when you do the tail to top method, the resultant becomes the hypotenuse. So on this diagram, you would have gotten this in maths. You've got a triangle ABC, and Pythagoras says that a squared plus b squared equals c squared. What I'd like you to simply add to this diagram is if we said that a was a vector, which you draw with a ruler, and then b is a vector, then the resultant would be the hypotenuse. Okay? Now we know how to solve for the hypotenuse. We use Pythagoras' theorem, and then we can also figure out the angle. Okay? Now and I've got it down there, but could you just write here that tan theta equals opposite over adjacent, and so theta is the arctan or shift tan, opposite over adjacent. All right? So we use Pythagoras to figure out the magnitude, and we use arctan to figure out the angle. And that's how once we've got the angle, boom, we can figure out what the bearing is for that final vector. Okay. Now this one I stole this from the physics classroom, and It's in the lesson about vector addition. It says that Eric leaves base camp and he hikes 11 kilometers north and then travels 11 kilometers east. So what you can see there, they've done a tail to top method. They've drawn a vector diagram. The resultant is now our hypotenuse. And look what we've got. We've got a right angle, we've got A, we've got B, we've got C, and then we've got the angle theta there. All right? So there they've shown it. I would go R equals the square root of 11 squared plus 11 squared. It's not really shown in the working out, but out spits 15.6 degrees. Sorry, try that again, 15.6 kilometers. And then, oh look, we've got A and B. We could also write, opposite and adjacent. So we've got our opposite side length and our adjacent side length, and we want to find out this little theta here. So we use the arctan. Okay, so that's it there. Now this is a special case. It's a equilateral right angle, so you've got equal side lengths, and that angle is going to be 45 degrees. So if you put into your calculator shift tan, 11 divided by 11, out spits 45 degrees. Okay? Which we can then say, all right, our vector, it's north 45 degrees east. So there is our final representation of that full vector. So we're taking everything we've learnt so far. We're expressing our vectors as arrows, combining them using the tail to top method, drawing in the resultant. Now we're using maths to figure out magnitude and direction. Aaron, get rid of it. Thank you. Okay, so let's do this. South and east. Now we want to go down and then right. So we could put a little dot about here. Okay. Now let's just not go 1 centimeter equals 100. Let's go 1 centimeter equals 50. And that way, instead of just drawing a 3 centimeter line, we can draw a 6 centimeter line. 6 lots of 50 gives 300. And then a 4 centimeter line would then represent 200. Okay. And then here comes our resultant. And we want to then find that angle there. Okay? All right, so I would go the following. R squared equals 300 squared plus 200 squared. And our hypotenuse is always going to be larger than the other side lengths. It's going to be larger than 300. Your calculator spits out 360.5 meters. In fact, I'll just put him down a little bit because then it says we can then use SOHCAHTOA to find. Now, we've just found the hypotenuse. So you could use SOH, you could use CA, or you could use TOA. But normally, you've been given opposite and adjacent already. So use what you were given at the start. So let's use tan. So that's why I always say just use tan. We'll go, the angle is the arctan of opposite over adjacent, which gives an angle of 33.7 degrees. Okay? And so finally, we can express it as S equals 360.5 meters. Now, what do we got? We've got south, and then that angle's 30, so it's south, and then we're sweeping 33.7 degrees east. Okay? Can everyone, sorry if I'm in your way, scroll up a little bit. Who's written this down already? Well, you can express that bearing another way, can't you? So now write the true bearing. So while people are still copying that down, I'll just quickly add up here. We've got north. You basically have to find that angle from north. It's a little bit of thinking here. this angle here is going to be 90 less 33.7, which is 56.3. 90 plus 56.3, 146. Not there, but remember, it's got to be a 3-digit number. So it's 146 capital T. Yeah, so again, we don't really provide decimal places. We express it to the nearest degree. Okay? In summary, it's a very simple lesson. We use Pythagoras to find the resultant magnitude and SOHCAHTOA to find the resultant direction. Okay. Cool beans? Ah, brilliant question. Wait. You'll do that in a moment. Let's turn the page. If you've already written that down, turn the page. We just used two vectors, north and east, or south and west, and it made a right angle triangle. We can use that for more than two vectors. Whatever we add, there will always be a right angle triangle. And the right angle triangle will simply be the east-west component and the north-south component. So let's try this one. We'll go 1 centimetre equals 50 metres. And could you put a dot around about here on your page, just so you don't run out of space? We're going to draw a 7 centimetre long line to represent the tree fitting. And then I'm going to go 4 centimetres up, and that will represent the 200. 400 east, that's an 8 centimetre long line. And then 100 south, which is a 2 centimetre long. So we could have done the lesson before yesterday with our tail to top method, and our resultant is then like so. Okay. Now I will zoom in a little bit for you. Okay. In fact, I'm going to zoom out in just a moment. If you drew that to scale and with all the correct directions, you could simply measure that red line like we did a couple of days ago. You could measure that red line and go, that red line is about 2.1. Using our scale, 2.1 times 50, it's about 105-ish. But that's not a very precise way to measure that. We've just learned about Pythagoras and SOHCAHTOA. So here's what we can do. You should be able to see that I can go little dash, 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 dash. You should be able to tell me those blue side lengths by looking at this shape. This guy's 100 metres, and this guy's 50 metres. And so look at that. There's our right angle triangle. Okay? So I've found the right angle triangle, and now I can find that little, that cut-off corner of this rectangle that never was. We can now go r equals the square root of 100 squared plus 50 squared, which gives 111.8, or 112 metres. So I use my ruler and it came out about 105. You might have measured slightly differently and you might have come out with 120 or 110, but it's not. Using Pythagoras, we get a much accurate, in fact it comes out as 111.8, so we can get it to the nearest centimetre. Okay, but we'll just round it to 112 metres. And then next, we could find this angle here, we could find theta. Theta equals the arctan of opposite, which is 100, over adjacent, which is 50. And we get an angle of 63.4 degrees. Yes? Absolutely you could. You could go this way. And in fact, if you did it this way, have a look at this. This angle was too big. Yeah, we want to get the complement to that. So what you could do is, yeah, you could absolutely draw your triangle like this, 50 and 100. And then, if we tried to find this angle here, maybe call it phi, we could say phi equals the arctan of 50 over 100. And that'll actually, if we flip out the side lengths, we actually get the complement. So in your calculator, if you did the purple values, you would get 90 less 63.4, which is 26.6. So this is a better one. Remember I said we always want to choose the simplest. 112 meters, east 63 north can also be expressed as north 26.6 degrees east. Okay, and that one's a little bit more simplified. The example I go with is if you had a fraction that was 16 over 8, well, you could express that as 8 over 4, or 4 over 2, or 2 over 1, or you could just write 2. All right, so you want to try and make your answer as simple as possible. So in mathematics, if you were given a fraction, you would try and simplify it as much as you could. Here we try and simplify it by giving the smallest angle. Okay? Now, what I would like you to do for the rest of the lesson, you've got one question above that I'd like you to do. Then you've got these 6 questions. So in total, we've got 7 questions that I'd like you to work through. And while you're doing that, if anyone's done the homework sheet, I'll walk around and you can show me and I'll tick your name off, put a happy face. Okay? All right, we'll leave the video recording there.